Introduction to Edge Computing. I am Dr. Rajiv Mishra, working as professor in the Department of Computer Science and Engineering at Indian Institute of Technology, Patna. Content: we will introduce you to the edge computing. Thereby, we will look upon the edge computing architecture and building blocks, edge computing for Internet of Things, advantages of edge computing in this lecture, which is titled as Introduction to Edge Computing. Let us recapitulate about the evolution or innovation of cloud. What we have so far seen is that the current state of the cloud provides the virtual machine which are running in the remote data centers, often exposed by the cloud service providers like Amazon, Google, Microsoft, or the storage that are being offered also through the remote data centers of these service providers. That is the current state of the cloud. Now, with the rise of Internet of Things and its applications, what we have seen in the waves of innovation of the cloud is that virtual machines are getting replaced by the containers, and the workloads, that is the IoT workloads, are moving towards container for different application developments. Then we have seen that data which are processed locally and the compute becomes more closer to the devices or the sources of the data is being enabled with the help of edge computing. So, this IoT data often requires data to be processed locally due to the latency sensitive applications. So, the compute becomes closer to the devices or the sources of the data. So, this becomes an edge, and this forms an edge computing. Now, then comes that the machine learning which requires the data which is being sent by IoT applications. So, that is called machine learning. So, that the data which is being generated by different sources of an IoT application often is being either sent to the cloud in an IoT pass, or it is not sent, it remains at the edge. Now, the machine learning has two phases. One is called the training with the data. The second is when a new data it looks upon on a trained model, it performs the inferencing. So, the training the model on the edge is also called inferencing. So, therefore, machine learning, if the data is too big, then it can use the cloud for training the model, and once the model is trained, it can be deployed to the edge for a new data. When it looks the machine learning trained model, it will perform the inferencing at the edge, no need of going to the cloud. So, these are some of the evolutions of the cloud, from cloud which requires the applications of IoT for a latency sensitive application. There comes the edge computing, and the machine learning is being now performed both edge and cloud together in this manner. So, this is what we have so far seen as the evolution of the cloud. Let us introduce in this perspective the edge computing. So, the edge computing allows the cloud to be genuinely distributed. So, that means earlier cloud services are being provided by centralized cloud data center. Now, with the advent of edge computing, this particular centralization becomes a decentralization. Hence, the edge computing allows the cloud services to be genuinely distributed. So, this is called the edge computing, where it makes the cloud genuinely distributed. Now, edge computing don't rely wholly on the cloud for all processing and data aggregation, collection and querying. Thereby, edge computing mimics the public cloud platform capabilities and it reduces the latency by avoiding the round trip and brings the data sovereignty by keeping the data where it belongs. Delivers the local storage, compute and network services. So, this we can see with the help of a little diagram that let us say that these are all devices and these devices very close by is an edge and very far is the cloud. So, the edge has this kind of logo that from the cloud it comes out and do the computation very close by to the source. Now, it has many edges, that is edge 1, edge 2 and so on. There are 3 different edges and thereby this particular way it forms this cloud truly distributed. So, again with this particular figure, let us see what we have so far introduced. The edge computing allows the cloud genuinely distributed, that is what we have so far seen. Second is it do not rely on the cloud for all the computing and data aggregation and querying. So, you can see that here even if the cloud connection is disconnected, the edge computing itself is sufficient to perform the computation. Hence, it do not require the connectivity to the cloud at all points of time. Third important thing is that edge computing mimics the public cloud platform capabilities. Now, meaning to say that whatever cloud can do, edge computing also has to perform all those functionalities of a cloud like services at the edge, that is very close to the source. So, all the cloud like public cloud services, every cloud provider is now offering the edge computing platform also. Therefore, it provides the cloud functionalities at the edge, that is very close to the source. This way, this edge computing will reduce the latency, because this distance is 1 meter to 1 kilometer, whereas the distance from source to the cloud is more than 10 kilometers. More than 10 kilometers, at least 10 kilometers. So, you can see that the distance is reduced, thereby the latency also, when you talk about this edge computing, it comes out to be 1 milliseconds in communication, whereas here more than 10 milliseconds of latency. So, it reduces the latency by avoiding the round trip and brings the data sovereignty by keeping the data where it belongs. Finally, it says that it delivers the local storage through the edge data centers, compute and network services with the help of edge data centers. Now, what do you mean by saying that edge computing makes the cloud distributed? So, edge computing makes the cloud truly distributed. The current cloud or the rather previous generation of the cloud was almost like the mainframe array, and it being accessed with the help of client server architecture, where very little processing was done on the client side, but all the heavy lifting was done by the cloud. So, here you can see that in this particular figure, you can see we are talking about the edge. So, here the edge is not single, but it is having multiple edge nodes, and this edge nodes being provided is providing the edge data center services, which is mimics the cloud like services. So, away from the cloud is the edge, and edge is very close to the devices, which requires these kind of compute, storage and network type of services. So, this whatever earlier the client side, when it requires heavy lifting to be done by the cloud, it can be done by the edge as well. With all the innovations in the hardware chips and with the affordable electronics, it makes more sense to bring the compute down to the last mile and actually keep the compute closer to the devices. You can see that this particular distance from the device to the edge is 1 meter to 1 kilometer, whereas if you see the distance from the cloud, it becomes more than 10 kilometers. Therefore, it becomes the cloud or compute down to the last mile, actually keeping the cloud closer to the devices by the edge computing. So, when the edge computing becomes more and more viable, where you do not need to rely on the cloud for all processing, data aggregation, collection, querying, you could actually run the computing layer very close to the devices, and this makes the edge computing becomes making the cloud services truly distributed. Edge computing mimics the public cloud platform capabilities and moves the cloud services closer to the data source. Here you can see that edge computing mimics the public cloud platform capabilities. For example, when you dissect an edge computing platform, you would notice that it almost has all the capabilities of a typical public cloud. So, in an IoT pass, we have seen the device management. It has data ingestion, that means the devices, when they send the data, it will be received by the cloud, and the cloud also knows about the devices and manages the devices. It has the stream analytics done at the cloud. It can run the machine learning model, and it can run the serverless functions. So, all these capabilities are predominantly available on the cloud to support this IoT pass that we have so far discussed. Now, with the edge computing, they all come to the last mile delivery. So, whatever was being done by the cloud, these are all capabilities are now being brought very close to the devices by the edge computing and run very close to the source of data, where these sensors and actuators are performing. Therefore, edge computing reduces the latency by avoiding the round trip and brings the data sovereignty. So, here you can see the cloud computing example, that image data, when it is input, the image is uploaded to the cloud, and the cloud then performs the image analytics, and then control commands are being returned thereby. The biggest advantage of deploying an edge computing layer is that it reduces the latency by avoiding the round trip that we can see over here, that instead of the cloud, this edge layer can also perform the processing very close by to the source, no need of accessing the cloud. So, the cloud is now no need or not a requirement in the edge computing. Thereby, sending the data to the cloud, getting the results back is the time called round trip time, and this is being avoided in the edge computing layer. Now, this edge computing layer is performed very close to the data, no need of sending the data to the cloud, therefore, it is called data sovereignty. So, it brings the data sovereignty by keeping the data where it actually belongs to. For example, this type of requirement of a data sovereignty, reducing the round trip time, is often required by many applications. One of these applications is the healthcare scenario. So, it may not be viable or it may not be compliant to actually stream the sensitive patient data to the cloud, where it actually getting stored and processed initially. Instead, the patient data should remain on-prem within the hospital premise, but it needs to go through a lots of processing and find out very useful insights, so that in case the edge computing layer is going to stay close to the healthcare equipment with the connectivity back to the cloud, and the architects and the customer engineers will decide what data will stay within the edge boundary and what will actually cross that and move to the cloud, maybe anonymized data. So, therefore, between deciding the data to be processed at the edge can go as it is, whereas if the data requires the cloud, then it has to be anonymized before it is being sent to the cloud in most of these scenarios where data privacy is important. So, with the edge computing, privacy is already maintained, whereas for the cloud data has to be anonymized. To protect the privacy. With this, let us understand the basic building blocks of edge computing. So, edge computing should have data ingestion capabilities, it should have the machine to machine broker, it should have the object storage, it should have the function as a service, and NoSQL and a time series database services. It should have the stream processing, and it should have the capabilities to perform the machine learning models, training and inferencing. Let us understand these basic building blocks. So, what do you mean by data ingestion? So, data ingestion is done or is being supported by the edge computing in the following manner. So, when a high velocity and high throughput data endpoints like Kafka endpoint that is going to ingest this particular data. So, you can see that the sources of the data can be either the batch, or it can be real time, or it can be streaming data. Now, this particular data is done, the data ingestion and various platforms are available, for example, Kafka. So, earlier Kafka endpoints for data ingestion was provided by for the cloud, but now it is also for the edge computing, has the same capabilities. And then the data will be put on the Hadoop or providing the storage for data ingestion. Now, to ingest something is to take something in and absorb something. It is the process of obtaining and importing the data for immediate use or storage in a database. So, either it will be performing the stream analytics or it can be stored in a database. So, data can be streamed in a real time or ingested in a batch. In a real time data ingestion, each data item is imported as the source emits it. Another basic building block of edge computing is machine to machine brokers. So, let us understand the broker, one such broker. So, edge will run the machine or a message brokers that will orchestrate machine to machine communication. So, let us see that this particular framework, which is called MQTT for IoT message brokers, called MQTT full form is message queuing telemetry transport. So, this is a type of protocol or a platform called broker here in this case. So, what it does is it uses the IoT stream data. Here you can see this is an IoT devices. These IoT devices, when they upstream the data, this will be received by the publishers. You can see a sequence of publishers are there, and then there will be a subscriber based on these different topics. So, for example, for a cloud there is another subscriber, and for let us say NoSQL database, that is another subscriber, and for interactive there is a different subscriber. They pull the data from with the help of machine to machine. So, this is one end of the machine point, that is IoT, the other end of the machine point is either the cloud or all that services. So, here instead of cloud, this machine to machine broker works for edge layer. So, here this will be the edge that you can understand in this manner. Cloud with the services outside the cloud is called the edge. So, this is not the cloud, but this is the edge. So, this machine to machine broker for the edge is being provided by different type of protocols, and one such protocol example is shown here is MQTT, provides machine to machine brokers for edge layer. They are called machine to machine brokers. Now, another important basic building block is the storage called object storage. So, the object storage may be unstructured storage, particularly to store the feed from video camera, mics, and anything that is unstructured go into the object storage. So, NoSQL time series database, that is more structured data goes into the time series database and NoSQL database. So, you can see that there are two types of data which we are talking about. One is called unstructured data. So, the data which is being ingested through different type of devices are called qualitative data. So, qualitative data is in the form of the data which is being generated by the sources, maybe either it is a text file, audio file, or a video file. They are often unstructured data, and once it is ingested into the edge layer, they require the object storage. So, the object storage will be in the form of key value pairs, that is called NoSQL data, or it's a time series database, now which is being supported for unstructured data, or it is called qualitative qualitative data. Now, on the other hand, there is a structured data, and structured data is called quantitative data, is in the form of numbers and the values. So, often you might be using only this quantitative data in your experiments, where the data is there in the form of numbers and the values, and the analysis you are performing in the based on the numbers, how much, what is the outcome of the data results is in the values. Whereas the qualitative data is not in the form of the numbers, because it is a unstructured data in the form of audio video files. So, it gives you the trends in the analytics, and in the analytics you can perform the forecasting and all that things using the unstructured data, or it is a qualitative data. So, you should be knowing about qualitative versus quantitative data. So, unstructured data is qualitative data, and for object storage it is a challenging how qualitative data is to be handled, and analytics is to be supported in the form of object storage. That is what we are talking about in the edge computing as a building block. Now, the next building block is the stream processing. It is the complex event processing engine. It enables you to perform real time queries and process the data as it comes. So, you can see that the input data from different sources. Now, when they are being streamed through a stream processing engine, so what it does, it as the data goes into the system without at rest. So, the analytics or computation has to be performed the data on the fly, and then it generates the output or the results. So, for example, every data point you want to convert from Fahrenheit to the Celsius, or you want to convert the timestamp from one format to another format, you can do it in real time. That is called stream processing, without storing and performing the computation. The next building block of edge computing is function as a service. To add the business logic, there is a function as a service which actually is responsible for running the lightweight compute. If you need to do more sophisticated, you could actually move to that function as a service. So, you can see that function as a service is to introduce additional business logic, and which can be done with the function as a service on the fly, the data. Now, coming to the another building block of edge computing called machine learning models. So, you can see that machine learning runtime is being supported at the edge layer, and for that it has come up the schemes of running the TensorFlow Lite, especially made for edge computing, cafe models and PyTorch. Using that, machine learning can be performed for its training and inferencing. So, you can actually process the data that comes in more intelligently and take preventive measures and perform predictive analytics. So, once you introduce all that, that is TensorFlow Lite, cafe models, PyTorch models. So, machine learning model is being supported at the edge computing, and various applications such as the intelligence out of the data, which is used in various applications. Let us preventive measures and predictive analytics can be performed with this functionality provided at the edge computing. So, let us see that edge computing architecture has three different layers we are discussing to summarize this edge computing functionality. The first is the data sources, that is the first layer, which comprises of sensors, database, event sources, machine logs, click stream and social media. They generate the data and called data sources. Second layer is called intelligence, where you can introduce machine learning algorithms on the data source, on the data which is being obtained through data sources, that is performing the machine learning either at the cloud, or you can perform the machine learning at the edge either. Then the next layer is about the actionable insights. So, based on the intelligence computation, the next layer is actionable insight, which comprises of visualization, dashboards, human to machine interaction, and so on. And three different layers, data source, intelligence, and actionable insight, forms the edge computing architecture. Now, let us see about the edge computing architecture. We are calling it as 3-tier architecture. So, the data sources, and by the way, edge computing is not confined to just Internet of Things, it could even be a non-IoT use cases. So, anything that generates data can be fed into an IoT like camera, click stream, analytics, gaming, etc. So, once it understood that data sources can be anything beyond sensors also, databases, click stream, social media, machine logs, they also becomes the data source. So, a lot of use cases relevant for edge deployment, and we can simplify this understanding of edge computing as 3-tier architecture. This 3-tier architecture is not the traditional 3-tier architecture that we are familiar of. So, it is just for understanding or a working architecture for understanding the edge computing. So, there is no app server, no database, no middle layer, and no upfront end. So, this is not the traditional 3-tier architecture, it is just an edge computing architecture, working architecture for understanding the edge computing functionalities divided in 3 different tiers. So, the first tier is called data source tier. So, the first tier is data source tier in the industrial IoT environment. This could be a set of devices that are generating the data. These are nothing but the original endpoints and from where the data is acquired and the origin of the source. Now, the second tier is called intelligence tier. Then there is an intelligence tier responsible for running the machine learning model. This intelligent tier cuts across the cloud and edge. So, there is a very well defined boundary between edge and the cloud, where the training takes place in the cloud and the inferencing it runs at the edge itself. So, collectively this overlaps between the cloud and the edge is this intelligence layer. Third is actionable insight tier. So, this actionable insight tier is responsible for sending an alert to the relevant stakeholders or populating the dashboards and showing some visualization, or even the edge taking an action to immediately shut down a faulty machine or controlling an actuator, and again the actionable insight takes place on the edge. So, this is not the physical boundary. In summary, you logically look at the whole architecture, so that the data source where is the original endpoint from where the data is acquired or the origin of the data. Then in the architecture of edge computing, we have introduced an intelligence layer where the constant machine learning training and inferencing is taking place, and then there is a insight layer, actionable, where you actually visualize the outcome from the intelligence through the dashboards and also perform actions based on those insights through the dashboard. So, that one way of visualizing the edge computing. So, in conclusion, we have covered the following topics in this lecture, that is in-depth concept of edge computing, wherein we have introduced by saying that edge makes the cloud truly distributed, the edge mimics the public cloud platform like capabilities and move the cloud services closer to the data source. Edge computing reduces the latency by avoiding the round trip and brings the data sovereignty. Building blocks of edge computing we have also seen, and then we have introduced 3-tier architecture of edge computing, that is data source, intelligence and actionable insights. Thank you.